Hello, welcome again. We are solving some questions of machine design. The topic is riveted joint. Question number 18 and 19 carries a common statement. The statement is a riveted joint with 4 rivets of diameter 20 mm is subjected to a load P as shown in figure. So this is load P and this is acting along the center of this second rivet, and the distance between rivets is 200, 200 and 200. All dimensions are in mm. Question number 18. If the working shear stress of the rivet is 100 MPa, then value of P is option A 78.5 kilonewton, option B 48.15 kilonewton, option C 38.15 kilonewton, and option D 90.15 kilonewton. Question number 19 is if the working crushing stress of the rivet is 50 MPa and thickness of the rivet is 10 mm, then value of P is option A 48.15 kilonewton, option B 25 kilonewton, option C 35 kilonewton, and option D 30 kilonewton. So this is the arrangement for this is rivet A, this is B, this is C, this is D. Okay, and the distance between them is 200, 200 and 200. So this is your center of rivet, center of arrangement, that is E. So the distance of C rivet from the center is 200 and distance of D rivet from the center is 300. And center of the distance of center of rivet B is 100, and similarly the distance of center of rivet A from the center is 300. So due to this load P, there will be a direct load on each rivet. So primary load on each rivet is P by 4. It will be equally divided. So PD will be P by 4. So as let F represent the secondary force and P represent the primary force. PD is same for all this. Okay. Now this P is at an eccentricity of 100 mm from the center of the figure. Okay, and it is causing counterclockwise movement. Okay, counterclockwise movement about this E. Okay. So the moment caused by this P should be equal to the moment caused by the secondary load. Suppose FD, FC, FB and FJ are secondary loads. Okay. Then taking moment about E, that is P into E, F A into LA, F B into LB, F C into LC and F D into LB. So P into E is equal to F A into LA plus F B into LB plus F C into LC plus F D into LD. Okay, so this is your moment equation. Now FA by LA and FB by LB and FC by LC and FD by LB should be equal, because if we divide F by area, then it will be shear stress, and it is a case of torsion, and torsion tau by R is constant. Okay, so FD by, as area of the rivet is same for each rivet is same, so F A by LA should be equal to FB by LB, and FC by LC should be equal to FD by LB. So this is the moment equation, and this is that this we have obtained from torsion equation. Okay, so now we can put all these terms in terms of FA. So FA by LA square plus LB square plus LC square plus LD square. Okay. So P into E is your FA by LA bracket LA square plus LB square plus LC square plus LD square. LA and LD are this is your LA and this is your LD, and this is your LB, and this is your LC. Okay, so this is and E is your 100, because E is acting at a distance 100 mm from this Putting these values, we can find out FA in terms of P. So that comes out as 0.15 P. Similarly, from this relationship, we can find out FB. FB is 0.05 P, and FC is your, again, LB and LC are same, so FC will be your 0.05 P and FB is 0.15 P. So we can see that the the value of FD is more than FD, and FD and PD are in same direction for Rivet D, and similarly FC and FD PD are same direction for Rivet C. As FD and PD are in same direction, okay, so as FD and PD are in same direction, so they will be added, and this is the and FD is more than FC, so this is the critical limit. So D is your critical limit. So the load on the critical limit is primary load, that is P by 4 0.25 P, and secondary load, that is 0.15 P. So that is 0.4 P. Okay. So this is your 0.4 P. And now question number 18 is the working shear stress is 100 MPa, then the value of P is. So now the critical limit is D, and the load on critical limit is 0.4 P. So 0.4 P should be equal to pi by 4 D square into tau, and diameter is 20, and tau is 100. Okay, so P comes out as 78.55 kilometers. Okay, so answer to question number 18 is A. Okay, and this will be your 78550 Newton, and we are converting into kilonewton, that is 78.55 kilonewton. Okay, so that is from the shearing of the rivet. Now we consider crushing of the rivet, then the area is V into T, and crushing strength is sigma C, and the load is your 0.4 P, and sigma C is given as 50, and T is given as 10, and D is your 20. So P is your 25 kilonewton. So answer is 25 kilonewton. So answer to question number 18 is A. Okay, and answer to question number 19 is B. Okay, 25. Okay. Okay, that is 78.55 kilonewton. 18 answer is 78.55 kilonewton, and 19 answer is 25 kilonewton. A and